Ladies and gentlemen, hello and welcome to One Take Studios with a topic that I am so geeked over it's ridiculous. I love today's topic. Alright, so we are talking about solving quadratic equations by graphing and factoring. And there's so much here that beautifully ties together that I want you to see it all. So we're going to get started, and we're going to start it actually with factoring. So I would like to solve this using factors. Well, I am assuming at this point that you can factor, which would be really kind of handy. If you can't factor, you should learn, because it's not going away anytime soon. As I say, if you can FOIL, you can factor, so I know that something times something is going to be x squared. So FOIL, first, f, there we go, the first one and the first one. X times x will make x squared. So the first, multiply to make the first. And the last, multiply to make the last. I need something that multiplies to make 8. 8, 8, 8, and we'll add to make a negative 6. Well, this is not bad. If I go with a negative 2 and a negative 4, they will multiply to make a positive 8. But if I check my OI, excuse me, if I check my OI, my middle term here, this is going to be a minus 4x minus 2x for a grand total of minus 6x. So these are my factors. All right, great. I'd like you to think for a second. I'm going to tell you over here, separate story. I have a number. Pick a number. 3. 3. And I'm telling you that 3 times something is going to equal 0. If I tell you that 3 times something is going to equal 0, what are you going to tell me? What's got to go here? The only way these will multiply and have this equal to 0 is if my question mark is actually a 0. This is something that's the earliest thing that we learned for our multiplication tables. Multiplying by 0 makes 0. And so it's this idea right here that will help us with this problem. Something that is called the zero product property. Zero product property. The idea that if I'm going to multiply and get 0 for an answer, then one of the things that I multiplied, one of my factors, had to equal 0 to make that happen. Transferring over here, I have 2 things that I'm multiplying and it equals 0. Well, based on my understanding of multiplication and zeros, that means that one of these, at the very least, one of these has to equal 0, because if I multiply to equal 0, that's got to be the case. Since it could be either one of these, and it could be both of these, they will just take turns. So my one factor, x minus 2, that one might equal 0, but the other one, x minus 4, could also equal 0. Well, that's going to give me a couple of solutions here, because if I add 2, x equals 2, there's one answer. And if I add 4, x equals 4, there's my other answer. Which one's correct? Both of them. They're both correct. Now, in certain circumstances, if we have a real-life problem, maybe one answer fits the problem better than the other. But technically, as far as the pure algebra is concerned, these are both answers. 2 answers. What's my degree for this equation? What is the highest power that you see? 2. How many answers do I have? 2. Coincidence? I think not. Ladies and gentlemen, if your highest power is 2, you should really have 2 answers. And if you can get that in your brain and hopefully keep it there, that helps with a lot of things down the road as well. Alright, so I've got 2 answers, 2 and 4, both solved to make this happen. I'm calling these answers, or solutions. Alright, so solutions, answers, whatever you want to call them there. However, I do want to introduce you to another word that would be roots, the even fancier word here. If you're talking about finding something's roots, you're talking about finding the solutions. So these are my roots for this particular equation. These are my solutions for this equation. So extra vocabulary, but it's a word that you're going to see quite a bit of, so it's worth paying attention to. Okay, now, hold that thought. Okay, hold that thought. Switching screens. X squared minus 6x plus 8. If you're taking notes and you look at your notes right now, this should look terribly familiar. I'm going to hit enter. I'm going to graph. Okay, so here's my equation, the x squared minus 6x plus 8. We can see that. And I'm thinking, what were my answers to my equation that I just solved? Because I just factored x squared minus 6x plus 8, and I got the answers of 4 and 2. Where on earth would I see 4 and 2 on this graph right here, 4 and 2? Did you see it? I'm really hoping that you saw that. The answers for solving this equation are the same as my x-intercepts when I have graphed this. 2 and 4 were my roots. They were my solutions. This thing crosses the y-axis, the x-axis at 2 and at 4. So my x-intercepts match up with my solutions. That is not accidental. Really and truly, I promise you it's not. Because, let's think about this. What I just graphed was f of x equals x squared minus 6x plus 8. What's the difference between what I graphed and my equation right here? The trinomial is the same. This one says equals 0. This one says equals f of x. This is just written in function notation. F of x is the same thing as y, correct? So if I take this and I graph this, I find out that I have x-intercepts at both 2 and 4, 2 and 4, the exact same place I had answers. Pick a point on the x-axis. 2, 0, 4, 0, 5, 0, negative 20, 0. What does every point on the x-axis have in common? X-intercepts, when you look at them as ordered pairs, all right, so an x-intercept, ordered pair, x-intercept, is going to be something 0. All of our x-intercepts have a y value of 0. That's what puts them on the x-axis to begin with. So this is 2, 0. This is 4, 0. F of x, 0. F of x, 0. Y, 0. Isn't f of x the same thing as y? So this graph, I'm looking for where does my y equal 0? Because where my y equals 0, I have x-intercepts. These are completely and totally tied together. You cannot separate them. And this is always true. Because if I'm looking for what solves here, I'm looking for the intercepts here because I'm looking for what would make this equal to 0. So let's add a couple more words. We said that solutions and roots are the same thing. Let's spread this out. What we are really saying is that if we are solving, our solutions are the same thing as roots. Why did I put a wavy equal sign? I'm kind of like messing with my math notation here. These are just different words used in different circumstances. So they're basically the same, but in different circumstances they have different uses. So solutions are the same thing as roots, and that's if I'm solving an equation. But if I'm graphing that exact same equation, the roots are the same thing as the x-intercepts. Okay, so we are saying that solutions are the same thing as roots, which if we graph is the same thing as x-intercepts, which x-intercepts occur whenever y equals 0. So we are looking for the function to equal 0. So we have one more name here, ladies and gentlemen, the zeros. So solutions, roots, x-intercepts, and zeros are all referring to the exact same topic, but under different circumstances. They're all answers. This is more in equation land, and this is more in function land. Otherwise, that's it. So this is a huge concept. Note to self, all of these things are actually referring to the same thing. Does this mean that on occasion that I wouldn't have to factor if I didn't want to find the roots that way, that I could maybe graph instead? Yeah, it actually does mean that. Are there potential downsides for that? Yes, sadly. But, all right, so let's take a look at this real quickly here. What if I had, okay, I'm gonna go with the sad face here, want. If I've got f of x equals x squared plus 2. X squared plus 2, if I just focus on that, I will tell you right now, it doesn't factor. Would the graph help? Parent function is x squared. It's a parabola. This is k, right? H versus k, this is k. So this is moving my graph up 2. So baby sketch says that I'm making a parabola that goes up 2 units and now looks like this. So based on my knowledge of transformations, this sketch-wise will look like this. Where exactly does this parabola cross the x-axis? Oh, that's right. It doesn't. So this particular function can't be factored, so we can't solve it that way, but also doesn't cross the graph on the x-axis anywhere, so double whammy, I can't find my solutions using either of these methods. Does it mean that it can't be solved? No, it can be solved, but that is a topic for another day. However, let me ask you this. This is x squared, right? How many solutions will this have? Tell me you said 2. X squared, right? This will still have 2 answers. It's just that it's not 2 answers that are on the x-axis. Interesting, interesting. All right, so what about this one then instead? So what if I have f of x is equal to, again, working with our transformations a little bit here, I'm going to get x minus 3 squared. All right, so that was k, that was on the end. This is h, this is a different type of movement because it's in with the x. So if it's minus 3 with the x, it's actually going 3 to the right. So 1, 2, 3, and again this is just a sketch, so my parabola is now here instead. Is this one as bad as this one? Because this one said that I can't find any answers through these means because it doesn't hit the axis at all. This does hit the x-axis, correct? It hits it at 3. And if you think about this, this actually is factored. What does x minus 3 squared mean? It means x minus 3 times x minus 3. That's what it means to square it. What if I set these factors equal to 0? If x minus 3 were to equal 0, that means that x would equal 3. Where does it cross? 3. I am really hoping some of you are going, yeah, but didn't you tell us there would be 2 answers? Because if it's x squared, there's supposed to be 2 answers, so where's my other answer for this thing? Since both factors are x minus 3, both answers are 3. And this is what it looks like visually when you have 2 identical answers. This is what's called a double root, to use our fancy language. A double root. So it's 2 of the same root, 2 of the same answer, and this is what it looks like. If your parabola turns around so that only the vertex touches the axis, that counts as 2 answers instead of 1. Just because every time I graph these, this is what happens, this is what it looks like. So, basic recap of all of life here. We can solve by factoring. If it's an equation set equal to 0, we find out what the factors are, we set the factors equal to 0. Ta-da! We have answers. Answers, solutions, also known as roots. If we graph, where that graph crosses the x-axis is the same as our solutions or our roots. So we are saying that solutions and roots line up with x-intercepts on a graph. And because these numbers, 2 and 4 in this case, because they make the y value equal 0, because they make the equation equal 0, these are known as zeros. So if I asked you for this equation, what are the zeros, you would still tell me 2 and 4, because they make the equation equal 0, they make the function equal 0. However, not everything factors, and not everything graphs nicely to have x-intercepts. Sometimes things actually factor really nicely, but we only see one crossing on the x-axis, and quadratics, things with an x squared power, always have 2. Always 2. It's like Noah and the ark, 2 of every animal. Okay, quadratics went on the ark in pairs. I'm telling you, the answers are in pairs always. Sometimes they're identical twins, but they're pairs. Okay? All right. So that is a gigantic thing. You should absolutely play with that and get more fun out of it because that's really cool. I'd like to play Jeopardy for a moment and work backwards. So what if I told you, just like in Jeopardy, that I have the answers? I have the zeros, and the zeros happen to be, we're going to go with 3 and negative 4. There we go. So I'm telling you that these are the answers. They are my solutions. They are my roots. They would be my x-intercepts if I were to graph. They make my function equal to 0. They are all these things. If this is the answer, can you tell me the question? Can you tell me the problem that they came from? Work backwards. We have the answers, right? If we have the answers, we know what factors they came from. So if 3 is my answer, that means that x minus 3 would have been the factor, because if I set that equal to 0, I get 3. And if negative 4 is an answer, it's a 0, what factor would that have come from? Now watch our signs here a little bit, because this was x minus 4, which produced a positive 4. What would produce a negative 4? X plus 4. Again, this is the factor. This is the 0. This is the factor. This is the 0. If I set this factor, x plus 4 equal to 0, and solve, I will get negative 4. So these factors produce those zeros. So just like Jeopardy, you start with the answer, you work up to the question. This is my function. I can put equals f of x and have happiness and joy. And for the sheer joy of it, I can also rewrite this then as a polynomial. I can FOIL. X squared, that's going to be a plus 4x minus 3x, so my OI is actually just plus 1x, and then that's going to be minus 12, and there we go. So if I'm looking for a delightful polynomial in standard form, this is it. And if I solve this, if I factor it, or if I graph it, I will see my factors produce these numbers. And if you graph this, I promise you, it crosses the x-axis at 3 and at negative 4. All right, so we can even work backwards and make that happen. So there's a lot of really cool stuff here. All right, this is what I call a party zone. This is a really important concept to kind of put all these things together in your brain and understand that they all fit together. We just use different words in different circumstances. All right, you guys got this. You got this, okay? All right, thanks. Bye.